Hello, I'm Breton, one of our MCAT tutors here at Inspira Advantage, where we help students get accepted into med school and other professional programs. On your MCAT, you can expect to see at least one question, maybe more, that tests your ability to calculate the oxidation states of a compound. We want to make sure that not only are you equipped to handle this challenge, but also able to solve it confidently and quickly, so you can spend more time on more difficult problems. Mastering oxidation states is not overly complex, but it does require a fair bit of memorization. I recommend adding the content from this video into your Anki or other spaced repetition flashcard program. To begin, we have to first understand that there is a hierarchy of precedence when it comes to assigning oxidation states. For example, the first thing we want to take into account are any free atoms. Well, what is a free atom? These include things like O2, iron by itself, sulfur by itself, really anything just by itself that has a zero charge on it is called a free atom. Brinkelhoff, any of your Brinkelhoff atoms or your diatomic gases are going to be these free elements that have a charge of 0. The second tenet we need to understand is that the sum of all substituent atom oxidation states will equal the net charge of the compound. For example, let's just take water. Let's take water, for example. The net charge of water is going to be 0, right? Water is uncharged. And we're going to see in a moment that the charge on hydrogen is +1 and the charge on oxygen is -2. The two positively charged atoms are going to contribute a total positive charge of +2, and the one oxygen is going to commit a total charge of -2. Well, these balance out nicely to equal 0, and this has to be true every single time. It has to balance out to 0 unless otherwise specified. Well, how could it otherwise specify? Well, if instead of writing a 0 here, I wrote a -1, which I'm not going to do because water is not charged. But that's an example of where it could change, but most of the time it's going to be at 0. Now, the third highest priority groups are more straightforward to understand. The next one we've got are the alkali metals. This is just your first row periodic table elements. Things like hydrogen, lithium, sodium, potassium, etc. And these we're just going to assign a +1 charge to them. After these, the next highest priority we have are the alkaline earth metals, or the second column. These are things like Be, magnesium, calcium, Sr, etc. These we're going to throw a +2 charge. Next, we have our hydrogens, which have a +1 charge. And then finally, we have our oxygens with a -2 charge. And finally, the lowest priority are the halogens in column 17. These are elements like fluorine, chlorine, beryllium, and iodine. Each of these are going to have a -1 charge. Once you've mastered this priority list and done some practice, you'll be ready to go on to your MCAT. Now you have the tools you need to start putting it into practice. So please check out my next video on how to actually solve oxidation state problems in an MCAT-like context. We're going to be combining things like oxidation and reduction states, which is a super duper duper testable concept on the MCAT. Well, I want to thank you for watching our video on calculating different oxidation states, and I will see you next time.